Good morning, students. Today we are going to discuss about the second part of the transformer. In the part of the transformer, we discussed about the introduction of the transformer, the basic laws, Faraday's laws of the transformer, basic working principle of the transformer, and the basic equation of the transformer induced EMF. Now we are going to discuss further about the transformer. So now we are going to discuss about the relation between the voltage, current and turns ratio of the transformer. So already we know that transformer is the static device which can transfer the electrical energy from one circuit to the another circuit without changing the frequency and without having the any electrical connection between these two circuits. That is the advantage of the transformer. The main principle of the transformer is the mutual inductance. By using the mutual inductance, transformer transfers the energy from one coil to the another coil. So now we try to discuss about the relation between voltage, current and turns ratio of the transformer. So voltage transformation ratio or voltage transformer ratio. So now you can see the core type transformer. Core type transformer having the primary winding and secondary winding. Primary winding E1, secondary winding is E2. E2, now the induced EMF of the primary winding is E1, secondary winding is the U2, E2, primary winding turns are N1, secondary winding turns are N2. So these are the basic induced EMS or basic parameters of the transformer. Now we try to discuss about the voltage transformation ratio. In the last class we already discussed about the EMF equation, induced EMF equation of the transformer. So that is E1 equal to 4.44 N1 FPMA. E2 equals to 4.44 N2 FBMA. So now divide E1 by E2 or E2 by E1, that is induced EMF of the second coil by induced EMF of first coil is given by E2 by E1 equals to N2 by N1. The meaning is the secondary coil ratio, that is the induced EMF ratio, is proportional to the number of turns ratio of the transformer, that is primary winding and secondary winding windings ratio. So that is we can generally call it as a K, where K is called the transformation ratio or turns ratio. We can call it as a turns ratio. Turns ratio is very important in order to step up the voltage or step down the voltage. The voltage step up and the voltage step down is depends on the turns ratio of the transformer. You can see that we are taking the induced EMF E2 by E1 ratio of the secondary winding by primary winding, then we are getting the secondary turns by the primary turns. This is nothing but a voltage turns ratio. E2 by E1 equals to N2 by N1. The points to remember is, so the thing is what happen is, depending on the turns ratio, we can say is that the transformer is acting as like that is the step up transformer or step down transformer or equal ratio transformer. We having the three different types of transformer depending on the turns ratio. If N2 by N1, N2 greater than N1, that is the secondary winding turns are greater than the first winding, that is the K greater than 1, that is the turns ratio is greater than 1, then the transformer is called step up transformer. Step up transformer. What is the meaning of step up? Means the voltage level is increased to the certain levels, certain high levels, that is called a step up transformer. Second case is if N2 is less than N1. Secondary winding turns are less than the primary winding turns, or K is less than 1, then the transformer is called step down transformer. Then the transformer is called as a step down transformer. The meaning is the supply voltage is high, that voltage level is decreased by this step down transformer. Case 3 is if N2 equals to N1 or K equals to 1, then the transformer is said to be equal ratio transformer. Then whenever the turns ratio N2 equal to N1 or K equals to 1, then the transformer is said to be equal ratio transformer. Now we try to solve some of the problems regarding this turns ratio. The first given the formula is calculate the transformation ratio or transformer ratio or transformation ratio of a 4400 by 220 volts single phase transformer. What he given that 4400 in the primary winding, 220 volts in the secondary winding. So that it is you can take an as the value is V1 and V2. What he asking is he asking the ratio, turns ratio is asking. So you know that the turns ratio K equal to V2 by Vn or N2 by N1. You can also says that the turns ratio is K equals to 1 by 20. So what we are doing is we having the V1 value, V2 value, then K equals to V2 by V1, that is the 220 by 4400, that is 1 by 20. Now we try to discuss about the another problem. You can study this problem. Now we can take the data. A single phase transformer has 400 primary turns, 1000 secondary turns, that is N1 equals to 400, N2 equals to 1000 turns. Calculate the transformation ratio. Now he given directly the transfer ratio. The formula is N2 by N1. N2 by N1 is equal to 1000 by 400, that is the 2.5 ratio, greater than, that is if it is greater than step up transformer, less than step down transformer. If it is equal, then it is called as a equal transformer. So next we try to discuss about the another parameter is the current ratio. We discussed about the voltage ratio. From the voltage, if you know the voltage, automatically we can know the current ratio. For an ideal transformer, the primary voltage ampere is equal to the secondary voltage amperes. Primary voltage amperes is equal to the secondary voltage amperes, that is input power equals to the output power. We can know that input power is voltage into current E1 I1, output power is E2 I2. From this we can calculate like this: E2 by E1 equals to I2 by I1. E1 by E2 equals to I2 by I1. You can also having like this: E1 I1 equals to E2 I2, or else E1 by E2 equals to I2 by I1 equals to 1 by K. 1 by K. K is the turns ratio. So this is about the current ratio. So this indicates the current ratio. Now we try to discuss about the relation between the voltage, current and turns ratio. Already we have three formulas. The current, voltage and number of turns related to one another in the primary and secondary of a transformer are E2 by E1 equals to N2 by N1, that is equal to I1 by I2, that is equals to K. So this is the basic principle underlying the operation of the practical all transformers. So practical all transformers are utilizes this one. E2 by E1 equals to N2 by N1 equals to I1 by I2 equals to K. So this is the basic principle under the operation of the all transformers. So this gives the relation between voltage, current and turns ratio. By using this formula, we can calculate the induced EMFs, or if we know the induced EMFs, we can calculate the turns ratio. If we know the currents, we can find the turns ratio and induced EMF. The thing is, we can interconnect these parameter, that is induced EMF and the turns and the current. We can interchangeably calculate these values. This is the relation between the voltage, current and turns ratio. Now we try to discuss the another topic. That now we try to discuss about the types of transformers. What are the different types of transformer, and what are the uses of this transformer and applications of the transformers, where we use these transformers? We try to discuss in this class types of the transformers. So the classification of the transformer, you can see on the basis of core material. What type of core material we are using? On that we having the air core transformer, means it does not have any core, simply it having the winding. Iron core transformer, if we use the iron core, so that is called as a iron core transformer. Air core transformers and iron core transformers. On the basis of the winding, depending on the winding, already we discussed core type transformers, shell type transformer. Core having the two limbs are there, two separate limbs are there, primary winding on the first limb, secondary winding on the second limb. Coming to the shell type transformer, the total winding under the farmer. The total winding is under the farmer, within the farmer, or covered by the farmer. And next one is on the basis of the function. Based on the function also we may having the transformer classification. Voltage transformer. The voltage transformer used to change the magnitude of voltage. So voltage transformer means what it doing is it changes the magnitude of the voltage. Current transformer. The current transformer is used to change the magnitude of the current. Current transformer is used to change the magnitude of the current. The next one is the impedance matching transformer. So what is the meaning of impedance matching? Means the impedance of the circuit is matched by using this transformer. That's why it is called as a impedance matching transformer. The impedance matching transformer is used to match the output impedance of one circuit with the input impedance of another circuit. Used to match the output impedance of one circuit with the input impedance of the another circuit. That's called as a impedance matching transformer. On the basis of the function, we have the three type: voltage transformer, current transformer and impedance matching transformer. And another one is the, again another you may having that one, that is the isolation transformer, instrumentation transformer. These two also based on the function of the transformer. Isolation transformer means used to provide the isolation between two circuits without changing the electrical parameter. The meaning is isolation means separation without having two circuits. Make use this type of isolation transformer used to provide isolation between two circuits without changing the electrical parameters. Another important one is the instrument transformer. Instrument transformer is very useful in the instrumentation, which is used to measure the voltage and current of a given measuring quantity. So this is the instrumentation transformer. So like this we having another classification depending on the basis of the frequency. We can know that depending on the frequency, you can see that is we may having the four types of transformer. The first one is power transformer. On the basis of frequency we having the first one is the power transformer. Power transformer is operated at 50 Hz line. Power transformer is operated at the 50 Hz line frequency and used to change the line voltage. Generally we use the 50 Hz line frequency. So if the frequency of the supply is 50 Hz, that type of transformer is called as the power transformer. Next one is the audio transformer. This audio transformer is used to transfer the electric signal of entire audio frequency range, that is 20 Hz to 20 kHz. This audio transformer is used to transfers the electrical signal of entire audio frequency range, that is 20 Hz to 20 kHz. Another one is the narrow band transformer. Narrow band transformer is nothing but radio frequency and intermediate frequency transformers comes under this category. Narrow band means these transformers are used to transfer the energy of specific frequency of the power supply, that is the radio frequency and intermediate frequency. The next one is the wide band transformer. Wide band transformer means video and pulse transformers come under this category. Video and pulse transformers are used in the wide band transformer. This classification is based on the frequency of the transformer. First one is the power transformer, second one is the audio frequency transformer, next one is the narrow band transformer, third last one is the wide band transformer. Next one is the on the basis of current ratings. On the basis of the current ratings, if we having the high current, then the transformer is called as a high current transformer. Next one is the low current transformer. If the current is low, so that is called as a low current transformer. So now we try to discuss about the another type of transformer. So the next transformer is, until now we discussed about the different types of transformer, classification of the transformer. Now we try to discuss in detail about these transformers. The first transformer is the power transformer. First transformer is the power transformer. you can see power transformer picture how it is. You can see the power transformer, simple power transformer. We having the primary winding, second winding. This is the practical power transformer. Now you can see the power transformer diagram. The ratio of the turns ratio is 1. So power we giving is the, we have the two lines black that is the supply voltage, red yellow, red green. So here what we are getting is the source voltage Vs, green, red, yellow, like that we are getting the one power transformer. You see the diagram. Now we try to, that is the core, that is the iron core, indicates the two lines, straight lines, gives the power transformer. Now we try to discuss about the in detail about the power transformer. Power transformer, it is operated on the 50 Hz line frequency, operated on the 50 Hz line frequency, and use it to change the line voltage, and use it to change the line voltage. It is also called as mains transformer. Power transformer is also called as mains transformer. Mains transformer. So it has one primary winding and more than one secondary winding. So this is the very important. Power transformer having the one primary winding, more than one secondary windings. These windings are wound over a laminated core. These windings are wound over a laminated core material to reduce the eddy current losses. A laminated cores are used to reduce the eddy current losses. So what is the eddy current loss means? What is the eddy current means? Whenever the induced EMF is induced in the core, that induced EMF may cause the short path to the temporary movement of the current or electron. The temporary current is causes the losses for the energy. These windings are wounded over a laminated core material to reduce the eddy current losses. This core is assembled using the E and I type of laminations, that is the E type and I type laminations. This core is partially assembled first, and after inserting the wound wise into the limb. This core is partially assembled first, and after inserting the wound wise into the limb. The remaining sheets are interleaved. The main advantage of the power transformer is power transformer having the one supply winding is there, but it may having the two or more secondary windings are there. So it has the primary winding and more than one secondary windings. These windings are wound over a laminated core material to reduce the eddy current losses. This core is assembled using the E and I type of laminations. This core is partially assembled first, and after inserting the wound wise into the limb, the remaining sheets are interleaved. Now we try to discuss about the constructional features of power transformer. So what are the features of the power transformer? Now we try to discuss. Power transformer generally prefer the shell type of construction. Generally the power type transformers are constructed on the shell type core shell type constructions they use. In shell type, the primary and secondary windings are wound one over the other on the center core. You can know that in the shell type, the cores are within the frame. The thing is, primary winding and secondary windings are wound one over the other. Two windings are wound one over the other on the center core. The primary and secondary windings are usually made with enameled copper wire. The primary and secondary windings are usually made with enameled copper wire. Finally, the transformer is impregnated with insulating varnish to protect the moisture. After manufacturing this transformer, the transformer is impregnated with insulating varnish to protect the moisture. Without having the moisture, what happens means whenever we put the transformer in the environment, some of the moisture may form on this windings. These windings, because of this moisture, they may harm the transformer and they may damages the windings. In order to avoid that, after after making all the things, finally the transformer is impregnated with insulating varnish to protect moisture. So now we try to discuss about the working of the power transformer, how it is working. Primary of the transformer is connected to an alternating source. As usual in the general type of transformer, the primary winding is connected to an alternating source. The induced EMF is developed in each of the secondary windings. Induced EMF is developed in each of the secondary windings according to the number of turns. According to the number of turns, induced EMF is developed in each of the secondary windings according to the number of turns which the windings have. If the windings having the more number of turns, it having the more voltage. Less number of turns, it may have the less number of secondary voltage. So now we try to discuss about the power transformer. Now we try to discuss about constructional features of audio frequency and radio frequency transformer. What is the audio frequency transformer and radio frequency transformer, and why we use this audio frequency and radio frequency transformers? So what are the constructional features? First we try to discuss about the audio frequency transformer. Audio frequency transformer constructional features. Audio frequency transformer diagram you can see. So we having the amplifier, primary winding and the secondary winding, and next one is the speaker. Generally audio frequency transformers are used to amplify the audio signal. Whatever the audio signal is there, that audio signal may step up or may step down by using this transformer. You can see the audio frequency transformer diagram. We having the amplifier, primary winding, secondary winding, and the speaker is there. So what happened, it is used to transfer electrical signal of the audio frequency range. This transformer is used to transfer electrical signals of a audio frequency range. It is also known as communication transformer. This audio frequency this type of that one is what you say, this type of frequency, this type of frequency is used here, that is audio frequency range is in communication. This type of transformer is also known as communication transformer. Communication. Constructional features of audio frequency transformer. So now we try to discuss about these features of the audio frequency transformer. Audio frequency transformer is also called as communication transformer. Its construction is similar to the power transformer, but the core material is a nickel iron of high permeability. So what audio frequency transformer having is, it is same as the power transformer, but only the change is the core what we are using is nickel iron of high permeability. Nickel material and iron material of high permeability are used for the audio frequency transformers. Its primary and secondary windings are wound on a core of laminated silicon sheet or silicon steel. The primary winding and secondary windings are wound on a core of laminated silicon steel. The high permeability core materials such as perma alloy, perm alloy and radio metal are used to reduce the size of the transformer. Used to reduce the size of the transformer. Constructional features of the audio frequency transformer. The construction is similar to the power transformer, but the core material is nickel iron of high permeability. Its primary and secondary windings are wound on a core of laminated silicon steel. Core of laminated silicon steel. The high permeability core materials such as perm alloy and radio metal are used to reduce the size of the transformer. Reduce the size of the transformer. It is used to change the voltage levels. It is available in step down and step up form to provide electrical isolation. It is available in step down and step up forms to provide electrical isolation. It is used in audio amplifiers for interchanging, coupling, impedance matching. So this transformer is also used in audio amplifiers for interchanging, coupling, impedance matching. We are using this type of audio frequency transformers. The next transformer is radio frequency transformer. We already completed the audio frequency transformer. Now we are going to discuss about the radio frequency transformer. Radio frequency transformer. So now we try to discuss about the radio frequency transformer constructional features. Radio frequency transformer diagram, you can see untuned primary windings, tuned secondary winding. Radio frequency is there. They are using the winding L1 and L2, C1 and C2. These two we having the two capacitors used to tune the circuit. Radio frequency transformer diagram. It is meant for operation at very high frequencies. Radio frequency transformers are used for the high frequencies compared to audio frequency transformer. Compared to the audio frequency transformer, so it having the very high frequency ranges for the radio frequency transformer. It is generally used for providing the radio frequency amplification at high frequency. The main advantage of radio frequency uh, transformer is it provides the radio frequency amplification at high frequency. Radio frequency amplification at high frequencies we are using. Now we try to discuss about the constructional features of radio frequency transformer. Radio frequency transformer, how it is? The radio frequency transformer, this is a transformer is made with an air core or ferrite core to reduce the eddy current losses at high frequencies. So what they are using is, for this transformer is made with an air core or ferrite core are used for the radio frequency amplifiers. So air core and ferrite core are used to reduce the eddy current losses at high frequencies. Reduce the eddy current losses at high frequencies. These air core coils wound with lidge wire over a wax paper or fiber bobbins. These air core coils wound with lidge wire over a wax paper or fiber bobbins. This transformer is provided with tuned secondary and untuned primary coils. Tuned secondary and untuned primary coils. So this is about the radio frequency transformer. We discussed about the radio frequency constructional features. So now we try to discuss about the another transformer, that is called as a construction features of intermediate frequency and pulse transformer. Intermediate frequency and the pulse transformer. Now we can see intermediate transformer just like the radio frequency transformer. Here also we having the capacitor 1, capacitor 2, inductor 1 and inductor 2. We having the construction features of IF and pulse transformer is given by, you can see the diagram how it is. It is a narrow band type transformer. What is a narrow band type transformer? Intermediate frequency transformer having the narrow band. So that is it is narrow band type transformer. It is designed to operate at a fixed frequency called intermediate frequency. This intermediate transformer is designed to operate at a fixed frequency called intermediate frequency. It is mostly made with air core or ferrite core. These intermediate transformers are used to manufacture using the air core of ferrite core. In this transformer, both primary and secondary windings are tuned to get good performance. In this intermediate frequency transformer, primary winding and the secondary windings are tuned, both are tuned to get good performance. So these transformers are enclosed in a metallic cases for screening as shown in figure. So this type of intermediate frequency transformers are enclosed in a metallic cases for screening as shown in figure. The next transformer is the pulse transformer. So pulse transformer means it having the pulse type of energy. This transformer comes under the category of wide band transformer. Pulse transformers also called as the wide band transformers. This is used to transfer pulses. This is used to transfer pulses from one circuit to the another circuit. Transferring the pulses from one circuit to the another circuit. The transmitted pulse is the transmitted pulse is either exact replica of the original pulse or it has undergone a change in its amplitude or polarity or both. That's why it is called as a pulse transformer. The pulse transformer is also called as a wideband transformer. The transformer transmitted the pulses is either exact. What it doing is the transformer transmit the pulses is either exact replica of the original pulse or it has undergone a change in its amplitude or polarity or both. Amplitude may change or polarity may change or amplitude and polarity may change of the pulses. This is called as the pulse transformer. The pulse transformer features are: the construction of pulse transformers depends primarily on lowest frequency. What is the lowest frequency? And power rating. Power rating of the transformer. These two factors determine the choice of the core. If you have the lowest frequency and power rating, if these two are satisfied, we can decide which type of core we need to use. The powdered iron core or ferrite core is usually preferred at these high frequencies. The pulse transformer, the core also important. The powdered iron core or ferrite core is usually preferred. Ferrite core is usually preferred at these high frequencies. At these high frequencies. For high power requirement, nickel iron perm alloys are used. High power requirements, we use the nickel iron perm alloys are used. Powdered iron core or ferrite core is usually preferred at these high frequencies. So now the leakage inductance and capacitance may be reduced. In this we may having the leakage inductance and capacitance may be reduced considerably by using the split winding shown in figure. What is that? Split winding. The meaning is the winding of the primary and secondary is splitted into two parts. That is called as the split winding shown in the figure. So this is about the constructional features of the pulse transformer. So now we try to discuss about the another type of transformer. So that is nothing but the auto transformer. Constructional details of the auto transformer. What is the auto transformer? So we have discussed in this class constructional features of the intermediate frequency transformer, pulse transformer, and the transformer is narrow band or wide band transformer. That one is the narrow band transformer. So name on wide band transformer is pulse transformer is called as a narrow band wide band transformer. So now we try to discuss about the constructional features of the auto transformer. What are the constructional features? So auto transformer is a transformer with one winding only, part of it being common to both primary and secondary winding. So what is the meaning is, in the auto transformer we may having only one winding. So in the one winding, one part is acting as a common to both primary and secondary, part of it being common to both primary and secondary winding. Primary and secondary windings are not electrically isolated from each other. Primary and secondary windings are not electrically isolated from each other. Its theory and operations are similar to that of a two winding transformer. Because of one winding, it is compact, efficient, and cheaper. The auto transformers, because of the using one winding, it is compact and efficient and cheaper transformer. It is used where transformation ratio differs little from unity. Wherever the transformation may differs from unity, there we use this type of auto transformer. The auto transformer is also used as an adjustable transformer for both stepping up and stepping down in the input voltage. The meaning is it is also used as an adjustable transformer for the stepping up and stepping down the input voltage. Step up auto transformer diagram, you can see some part of the winding is used as the primary winding, so some part of the remaining winding is used as the secondary winding. You can see the step up auto transformer. The meaning is step up means secondary winding turns are more compared to the primary winding. Step down transformer, you can see the step down transformer, you can see that one it having the in the step down transformer diagram, you can see. So what happened means the total winding total input total winding is taken as a input supply, and some part of the turns are we are using for our connecting the load. So that part is called as the step down auto transformer diagram. So this is the step down auto transformer diagram. So these are the some of the different types of transformer which we are discussed in this class. In this class we discussed about the classification of the transformer. So what are the different types of transformer depending upon the frequency range, depending upon the core material which we are using, and depending on the operation of the transformer. So all these classifications are we discussed. After that we try to discussing about the different type of the transformer, that is the intermediate frequency transformer, power transformer, and next one is the audio frequency transformer, radio frequency transformer. After that we are discussing about the auto transformer. In the auto transformer also we may having the step up transformer and step down transformer. The beauty of the auto transformer is some portion is in this we may having the single inducting wire, so but there is no electrical isolation between these two circuits, directly they two also connected. So some portion of the turns are taken as a output side, the total portion is taken as the input side. So we discussed all these things in this class. So remaining topics whatever we have, those are we discussed in the next class. Thank you.